So big welcome to everyone from SUN, that's the Space Universities Network, whose aim is to support the space higher education community. And just to remind you what SUN is, we are aiming to produce a workforce of skilled graduates by sharing best practice amongst all our university and FE college members. We're trying to keep our curricula relevant, and we're trying to promote all sorts of space teaching, not just science and engineering, but medicine, law, and all the different space disciplines. Who is SUN? Well, we've got members in most of the universities around the country. If your university is not yet a member, do please contact us. And the way you can do that is through our website or through our email. So I will now stop talking about SUN and just stop sharing my slides and introduce our speaker. Professor Susanne Schwenzer is Professor of Planetary Mineralogy. She works at the Open University, where she's the Associate Director of Astrobiology OU, postgraduate tutor in the School of Environment, Health and Ecosystem Sciences. And very excitingly, she is part of the NASA Curiosity Rover Science Team, an interdisciplinary scientist of the ESA Rosalind Franklin rover mission, of the Mars Sample Return Campaign Science Group, and the National Academy's A Strategy for Human to Mars panel. And so we are very excited and delighted to have her talking to us about a very interesting education opportunity that the Open University are running called the Mars Mission Simulation. Over to you, Susanna, and thank you so much.
Thank you, Lucy, for that introduction. I'm still not quite used to the title professor because it was senior lecturer until last year, but I'll take it. Thank you very much. So how you're seeing Mars mission simulation, it is a teamwork activity in a real life scenario. And you are seeing on the upper right of your screens a real picture. You see in the middle, these two little ears, that's part of the rover's arm. And you see the landscape and everything as you would see while you are part of that mission. This all came to be because we set up a master's course in space science here, and we needed to do something in terms of teamwork and employability. Most of you will know we are a distance learning provider, so we do not have the opportunity to get people into a room, distribute some whiteboards and a problem, and for them to solve, to learn how to work in a team. We need to be different here because our students are distributed across the country. They are mostly working full-time. They might be also carers. They might have disabilities, additional needs. And so we need to care for that very mixed cohort that certainly doesn't have time to come to a room from 9 to 11 in the morning of any given weekday. And with me having just been on a ESA mission simulation that happened in Harwell for the ground team and in Chile for the Mars team, like those who actually moved the rover around, I thought that this mission simulation scenario would be really beneficial for us because we could fit it into our study times in the evenings. It would be face-to-face in real time. You can't work in a team if you are not there. However, it has elements for people to contribute when they are not there. And in the 26 missions that we had, or something like this, that we had here at the OU for our OU students, plus a handful of others, we had people around the globe. We had people on ships off the coast of Africa or in Asia, in America, even one who was almost reaching Antarctica at the time they took part. So it is something that you can do distributed across the globe and time zones as well, although it is beneficial if the main team is in the same time zone. And with that, I'm going to start to say, and we started the preparations in 2014, and the first of our missions ran in 2017. So this is our timeline. This timeline, we have a slide at the end that Ben, I think, will present, because we had a Sunbit in to do some improvements, and Ben is the PI of that. So I am just the facilitator of today. Ben is the PI. That's Dr. Ben Dreyer, who is a research fellow in the School of Physics. So our timeline is this. We set them up on Saturday with a briefing. They have a handbook and that they can read before. They do a bit of a Mars before, but our cohort is very, very diverse. We have everyone from engineers to STEM scientists and sometimes beyond. As long as they can do the math required for some parts of that module, we don't look what degree they have. And so we need to bring them up to speed, and we have a handbook for that, and they go and study Mars for a little bit. On Saturday, I brief them, or we have other facilitators. So on Saturday, there's the briefing. They get the introduction to the tools, to what to expect in that week on Saturday. There isn't a week or several weeks lead time. It happens on Saturday. It starts on Saturday. They know nothing on Saturday at 1300. They know everything that I will ever tell them without them asking a direct question on Saturday at 1500. Because that is so pressured, I have a drop-in on Sunday where they can or cannot come. Usually about half the team makes the time, where I answer all the questions. And just before that, we also open access to the tools. There is a specific online environment. We open that just before, and then we ease them in a little bit on Sunday afternoon. On Sunday evening, we drop the ball, we start for real, and off they go. I will show you with what they go off in a minute. And Sunday to Thursday evening, 19 to 2200, they do their mission planning. They uplink their plans to the rover. Then a team of us goes and executes that the next morning, releases the data in the afternoon. They have time in the afternoon to look at it if they have. And that's when, especially people who can't make the evenings, come in and chip in and analyze data and so on. We leave the team to organize themselves and to deal with these problems themselves. We just say, we expect you that one of your sub-team is there. We expect that you do this, but they need to organize this. And we are very hands-off. And we might make a slightly snarky remark if we see it doesn't work, but they need to do this, and they get tossed in and they need to do this. And on Friday evening is a debrief, which we usually start with them telling us whether their mission is the one that ESA should send the big spacecraft to, because they have found water and they have found everything. And quite often teams take that in their stride, and they prepare really good presentations. At this point, often the teams, actually all teams that I've ever run, have coagulated as a team, and they are excited, they are hyper, and they pull off whatever they can in the time available. And then I go over what they could have found, what they did real well. I always try this to be very, very positive. And even if the geology isn't quite right, I try to find the positiveness in it, because if you have a team of engineers who have never interpreted geology and they find a snippet, even if it's not 100% what it should be, I tell them why they thought what they thought and why this is logic, and then say what it actually is. I try to be really positive about that, especially if I don't have a single geologist in the room. And that happens quite often. And you can run it for geologists, and it's a very different mission, or with geologists, it's a very different mission. It can do it. It works just as well with or without. We can run compressed schedules, and I can talk about this a little bit later, but this is actually ideal for the students because they have a little bit of time to go and search, what do I actually do? How does a basalt look? What minerals are in a basalt? That kind of thing. Settings. So we have a real rover that you could pick up if you were allowed to, but we don't let anyone behind the curtain. We have a real landscape. You've seen a peak on the first picture. I have a few more pictures. It's 7 tons of sand and 0.5 ton of rocks. And the participants see what I call a map. It is an overhead image that's degraded to the same level of resolution that you would have from an orbiter image around a planet, in this case, Mars. And so they know, and they get the size of the rover, so they know roughly the size of their playground for the week. And the rover has real cameras. So when they drive and take pictures, they take pictures of that landscape. And you saw one of those pictures that a mission team took on the very first slide. The rover drives where the participants tell it to go. We are not doing anything. They are planning the plan on that overhead image with all the tools that they might. Sometimes it's P times thump and then it goes horribly wrong and then they improve. Sometimes they are really good at searching and also spotting where we haven't told them the full picture yet, like there's a mast cam, there's a stereo cam. When they look backwards, they can see the tracks in the sand. They can drive wherever they want. Unless they drive into a dune, that's a no-no. We tell them that. And in reality, that's also so they can't drive off beyond the actual landscape into what is then the virtual background. So that's all blocked off by dunes so that they have to stay in that area that they can actually drive in. So the rover does not have real instruments, but we simulate two instruments that are on the Curiosity rover. That's the APXS, the Alpha Particle X-ray Spectrometer, which is on the rover's arm and gets put down to get rock chemistry. It is very slow because you have to be within 20 centimeters, like arm reach. For the real rover, it's a bit closer, but it's a bit more because the real rover is bigger, but you have to be within reach of the arm. You have to stand on all 6 feet, which we don't do here, but the real rover has to. And you deploy the arm. So it's an overnight thing. It's something that takes a lot of time on MSL. The real rover, it takes a lot of power here. And then there is the LIBS, the laser-induced breakdown spectrometer, which is a laser that shoots at the distance. You can get hundreds of data for virtually no cost in our mission. Curiosity is slightly different, but they can get hundreds of data at virtually no cost. So you have these two instruments. The APXS also gets the trace elements, which the LIBS instrument doesn't get. You get more information from the APXS, more precise information, but it's more costly. The LIBS you can use as a reconnaissance instrument. You can overwhelm yourself with data, and it's that balance. And these are two teams, each one operating one. And we will give them data from the actual Curiosity mission for the LIBS and Curiosity and the Mars exploration rovers for the APXS. So they are dealing with real Martian concentrations that they can map, if they choose so, onto the peer-reviewed literature that came from these missions. There's an exception in there, which is our little secret thing for them to find. And that's a secret. And I won't say anything about this, but there are surprises in the landscape, not like a Martian or something, but actual things that we have found on Mars before that we are not talking about, and that they can come around the corner and think, what's that suddenly in our image? And that they can figure out or not. If they don't, fine. We do not assess the geology they do. We do assess the team. And not even that. I come to that later. So the participants can choose between several paths. They can choose to go back. They can do whatever they want in that landscape. And every path allows to answer the mission goals, some better than others, but it's also not the point of the exercise to have the picture perfect answer to everything. The participants will be divided into sub-teams. So there is a mission lead team. There is a mission science team. I already mentioned APXS and LIBS as two different chemistry instruments, and they each are a team. There is the mast camera, which is basically the eyes of the mission. That is a team. And then we have the driver team. So there are 6 teams, and 18 works well. We have run with 2022. We can run. If you get below 10, it gets really stressful. Every sub-team will perform a different role and has different tasks and different things that they need to do. The LIBS team usually needs at some point to get to grips with big data, 100 data points of 20 elements or something. But and each team has their own requirements. The APXS team is probably the one that's the lightest on the data and on the decision making and everything. So if we have people who might not be comfortable in the environment, they quite often get to the APXS team. APXS is also not operating every time, and which is a question then for them to argue for it, because it's the single most costly thing in the entire mission. And they need to work together to decide what are we going to do? How are we using our budget, which is mostly an energy budget? And we are not getting involved. We might make a guiding remark, more or less snarky, in a chat box, but we are not getting involved. We are briefing them. We are helping them on Sunday to get to grips with their interfaces. We are on hand to ask any question that they have. If someone comes and says, what should we do here? I'll work through with them, or many of my co-facilitators. We are usually 4 to 5 people in the room. They go into breakout rooms when they're with their sub teams. At one point, we are in these rooms, and then we talk about the thing, and we say, wouldn't you think you want to argue a little bit more for your instrument? Or we give hints if this is a room full of engineers and they should interpret geologic data. We give hints what to Google, that kind of thing, but we are not giving them solutions. This isn't undergraduate in that sense, but we have had undergraduates do it, and they got on quite well, as long as they understand there is no textbook, and the answer isn't in the textbook on page 5. So, and with that, it really feels real. The participants get nervous, they feel time pressure, they feel anxiety when they have to press the submit button and commit and can't undo anything. And we also play with this a little bit. They decide, okay, we make a roll call. Everyone has said we are ready. Now the mission lead needs to hit submit. And then we pop up a window and say, you can't undo this. Are you sure? And just to make it feel real, but also put them through this artificial but feeling real pressurized environment, because that's part of the real workplace. And we provide that safe environment for them to actually try this out and to encourage the team to support each other. If mission lead isn't sure to press the button, do another roll call, share that responsibility. And they are usually excellent at it. I have not seen in 29 missions now, I have not seen a team which wasn't excellent in that. Not a single one. And we encourage them to do it. It's one of the main things that I talk about in my briefing. And I think it's a learning experience for them, because they know it's a safe space. They know it's just a mission simulation, just a part of a course. But because it feels so real, with the pressures, with the decisions, with us saying, if you drive into a dune, that's at the end of the mission. Make sure you all agree, and that type of thing. And we indicate we will let them fail, but it is still a safe environment. It is not a $2.9 billion rover on Mars that they have set into a dune. It is, in the end, a learning exercise. And the teams are also encouraged to bring their entire knowledge. I had questions such as, oh, for work, I use GIS. May I use that? Of course you may. Bring your entire self, bring everything you know, and contribute that to the team within your role, but also beyond your role. If you happen to know GIS, but you are APXS, why not assist the drivers? We have single rooms where just sub-teams have access, but we also have collaboration rooms, all set up in Adobe Connect, which is our system that we normally use, but any other video conferencing system goes as well. And so they can choose to collaborate, and they have the tools for it. So this is how I start them. That's my last slide of the briefing on Saturday. And you see the map, the orbital image. And my first question always is, where is the rover? And then I open the whiteboard to draw, which I can't hear. So take a moment for you to just get a feeling for this. And where's the rover? Think about it. But here you also see the problem. It is a degraded image, of course, but it is the real resolution we would have on Mars. So if you zoom in there, you see you have a bit of a shadow. You have the first problem, and you have them run into a rock. We do have proximity sensors that stop them before they crash the rover. And but that's all they know. When they start, they have this orbital map. on Saturday. They know nothing beyond that yet because they do not have access to the interface on Saturday, and we make them think about this. If they think about it and say, oh, we have a mast, how high is that? We will answer. If they don't ask, fine. The engineering guy sits there, twiddles thumbs. We have someone who logs in and says engineering, and so they usually ask them. And this is their interface that they have. They have a data viewer. They have the rover planner. You see the rover planner here. It's basically a Gantt chart that they can put tasks in here. This is the mission lead view. Mission lead needs to balance power at the end, which is always, I call it power Tetris. And then they sometimes have to take things out of the plan. And these are hard decisions and really intense discussions. And so they pull the commands in here. If we could open, but I can't at the minute because that's just the PowerPoint. If we could open this, you would see they have to switch on the mast, switch on the mast heater, wait for heating, switch on the camera, take their images, command at which angles, and then switch everything off again. Because if they forget to switch something off, then it will draw power, and that will not go well. And we encourage them to do what's called the plan walkthrough, so that they open every one of these things and read them out loud. And the person who owns it, like who has put the plan together, says check or okay or go at the end. And everyone looks, because everyone can go 1, 2, 3 things switched on, 1, 2. Oh, there are only 2 things switched off. You don't need to know the instrument. You can simply count. And that's really how we do it on MSL as well. And I encourage them and I tell them, professional engineers who drive a rover for close to 13 years walk through every plan line by line every single planning day. You can do that too. And I think that's the power of this, that we know how it really works. So that's the tool, and it basically runs on any PC, any laptop, anything. Participants really just need any way to open a web browser of any sort of definition. Chrome and Firefox usually work best. Edge sometimes throws a little bit of a wobble, but it works. That's all they need. If we do it, if we run it, we provide Adobe Connect that they can download the app from. If we were to run it for someone else, then you could provide that. And we have a forum for discussions, which is basically a chat function forum, and like a asynchronous, a forum. And we have a wiki for the data, and we don't make them write a report. We say the wiki is your report, and encourage the mission scientists to actually organize it so they can also keep track. So what are the learning outcomes? Because this is all, it sounds fun, and it is fun, and the teams all have totally gotten into it. And what we observe is that they say, oh, I can only make Monday and Tuesday, and maybe the debrief on Friday. And then they end up being there every evening anyway, because it hooks you, it draws you in. David has sat through it, and he said, oh yeah, maybe if you don't need me anymore. No, he was there every evening, because it just draws you in. And we do the same. I often say, oh, I take Wednesday off if someone else facilitates, and then I'm there anyway. What are the learning outcomes? All students will have tried out within their subteam. They don't change subteams during the week, but within their subteams, leading a decision-making process, facilitating, or arguing for their point in a wider team. They will all have had the duality of sometimes being a leader of a sub-team or the entire team in case of mission lead and mission science, or the drivers need to lead a discussion to, no, we cannot go there. Every team has points in the mission where one of their sub-team needs to start leading the whole discussion. But they also have to be followers. And someone says, we are under time pressure. Can someone just see how many dunes are in our way? And they think, okay, I have a bit of time on hand, and be a good team member. And we point this out kind of in our introduction, that what the team is, what team member is, how teamwork works. And we certainly spent quite some time in the debrief to pointing out where they did real well. And again, I'm trying to be very, very positive and spin things by good examples. And all students will have to handle themselves in this time-pressured situation, make decisions with incomplete information. That's just mission, when I got trained in a new role, Dr. Vasavada, the PI of the Curiosity team, said to me, first of all, before we even start, we will always make decisions with incomplete information in a time-pressured situation. Take a step back, do whatever you can, do the best job you can, do in the time available. And that's called complexity in space flight, in the time available. You could do a job in 3 hours, but you only have one, so you can't do it. Complexity is too high. And so that element of realness and that our facilitators all can bring, because all of our facilitators have either mission experience like me or mission simulation experience. And through that realness of the mission, it is not perceived as teamwork, which is actually the good thing about this. The focus is on the mission, and people react as they would react in real life and can then actually reflect on what they did. The students report higher confidence in presenting and data and facts in front of others. They report higher confidence in making points of discussion. We had some quite moving examples of people saying, oh, but I am neurodiverse in some way, shape, or form, and I cannot do this. And we try to facilitate that they can contribute. And the most heartwarming case I have ever seen was a mission lead who actually was on the autistic spectrum, said, I can't do this, but you put me into the mission lead role, because as a distance learning provider, we didn't know that. We saw they were very active on the chat and everything in other parts of the course. And so we put them in the mission lead role, and they disclosed it to their team members. They did the moving of the interface and all the nonverbal things beautifully. And on the last day, they led the thing. And they gave me a call to say they would never have thought in their life they could ever do this. Things like this happen, not every mission, but they have happened. And I think that's why we are all teachers, why we all educators, and why we do these things for people who have these really life-changing experiences. And in our course, the exam element is a self-reflection. I got a question earlier in how to assess and how to certify. For us, we have an element of our final exam that carries about 20% of the weight of the final exam, where they self-reflect on themselves within the team. And so what we are asking them is to give 3 examples of where they did really well. Because I personally believe, and I have that on the next slide as well, I personally believe we all gravitate to where we are good at. If I am really good at math and engineering and calculating numbers, I might want to do a job like this. If I'm really good at presenting, I might want to do a job like this. And finding this out during your studies for real, I think is very valuable, because you can make your career decisions there. So, and that's why I asked for 3 things that they did really well and argue why they did this really well. I asked for 2 things where they could improve, because that's also important. And I asked that they take one of the things that they did really well and how they could even further improve on that. That's what we ask in our exam. And so if anyone wanted to adapt that, that would be fine. It is very student and person-centered. It is not a reflection on the team. So it is not to say, oh, M-Lead always put so much time pressure on us. No, 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 no. M-Lead, if you are a driver, you are a driver. You reflect on yourself and not on the team as such. And so all students have to contribute to mission activities. There is no hiding place, but there isn't no hiding place because we go behind the library shelves and chase them out there. There is no hiding place because all hands are needed on deck and they just need to do it. And some people are more data people and some are more outspoken, and that's for them to organize. That's just what they want to do. We do not say, but you haven't done this, you need to do this. No, that's up to them. They do what they are doing best, because it is about finding your way to contribute to a team. And in that sense, what I said earlier, we try to encourage, we also with that indirectly encourage students to find and understand their own niche. We do have a strictly safe environment, and students react amazingly well, and they are exceptionally supportive of each other. If someone can't make an evening, they come in and they brief them and they bring them up to speed. You see on the forum that they write little notes for them. If I have not seen in the 29 missions I did a single team that deviated from being amazingly supportive to each other. Of course, there is the odd flare up of temperament or something, and usually they go, all right, we need to be working as a team. The clock is ticking, and they sort it themselves. If not, once or twice in these 29 missions, I had to take someone aside and had to say, just breathe. It's a lot of stress, just breathe. And then they apologized, but I also then encouraged the team to let them just come back and let this be water under the bridge. And that works. I had never have a team blow up in 29 missions. And I think that's pretty good statistics. The students also learn to ask questions. If they go on a fishing expedition and say, engineering, what else could I know about the rover that I don't need now? Engineering will say, engineering doesn't know the answer to that question. And so it is that kind of ask a precise question, you will get a good answer. And they learn to search for information and put the piece together without being spoon-fed or their handheld. There is no textbook, no step-by-step guide. They learn by being reliant on themselves. This whole thing, as you might guess by now, is not easy on the facilitator team. So we need about 2 days to set it up, divide the different roles. We need to have all participants access to OU systems. So there is a bit of an administrative burden on us and on the participants because they need to make an account and that kind of thing. There is one main facilitator who spends about 2 to 3 hours behind the scenes looking at the forums, giving some hints, making sure everything rolls. Being in the Mars yard in the morning to execute the plan and answering questions of all sorts. And the facilitator is online for the 3 hours of planning every day and gives the debrief, sometimes with others. There are co-facilitators because on Sunday, when they first go into their breakout rooms, have never done anything on their interfaces, then it is really important that there are lots of people and we have them, and there is one of the engineers present as well. And the next morning, we need to execute the plan. The Mars yard needs setting up. I always call it de-spidering because a large area is going to have life in it, and which we don't want to photograph. But also, there is this blue question, and that if you run it from your institution, we would kindly ask a person who knows the students to be there. We normally have one of our tutors who know the students from the tutor groups in the room because 20 people, like 20 students and 1 week, life is bound to happen, especially for our cohorts, which is that age group between 25 and 45 who might have children and caring for parents. They might have a full-time job. And so we have to have someone in the room who is able to, if someone gets a panic attack because life gets in the way, be able to smooth that over. I can do a lot, but we usually have a person who does pastoral care in the room. We never had them need to do much except in circumstances where suddenly a relative passed away or got into intensive care or something like this. It's just statistics. You know, these things happen. Overall, this is a lot of work because you have 2 to 3 people full time for the week, if you count all of the hours. But it's fun and it's very, very rewarding. And with that, I think, Ben, you wanted to talk to that part?
Hi, everyone. Yeah, I just wanted to, I mean, that was a great description of what we do with our students and what we did with the Sun students a couple of weeks ago. But I thought I wanted to touch on, what we were able to do with the funding that Sun provided and what we are looking to do in future to be able to use this experience, this simulation more widely and enable more students to benefit from it, because we think it's a really powerful, and I think the Sun members who came along to have a look at what the students were doing probably took away that it's quite a powerful experience for the students and really helps develop them and helps them, as I said in the chat, helps them to evidence some of those soft and transferable skills like being able to communicate, lead a team, work under time pressure, things like that. So it helps them to evidence that going forward as they look to progress in their careers. So we've been using it for a number of years, I think 7 or 8 years now, Susanne, on our Space Masters course. And it's really been a facility that we use it in August, and then it's left for the rest of the year, and we have to dust it off every year, make it pretty and workable. And so over that 8 years, you know, some of the hardware and things have aged a little bit and needed a bit of TLC. So with the Sun funding, we've managed to have a backup rover, so it's more reliable, and improve some of the electronics and things that we're doing as well as work on some of the software behind the scenes to make things a bit quicker and easier for us to do the work that's needed in the yard whenever we run these. So we're really interested in being able to work with the Sun universities if you're interested in, you know, what this could bring to your curriculum, to be able to use it for that. But I think a lot of you are going to have slightly different needs of what you want the learning outcomes to be. So we have a certain operating mode. Susanne talked a little bit about a compressed operating mode where we've run it over a couple of days. So you would have several planning sessions in a day. But I was also thinking, as I was writing these slides, that perhaps for a traditional in-person university, something like you run a planning session once a week or twice a week with a longer time in between to look at results could also work. So you could maybe take up a lab afternoon with a planning session instead of running labs or something. That's certainly something that we could do as well and run it over a longer time period. Also, our learning outcomes are what they are, and we assess based on the students' own self-reflection of how they performed in the week. So that's 20% of their final assessment is that self-reflection, and alongside that they do an 80%. It's a CubeSat proposal, so that assesses more of the technical learning outcomes that they have from the module. There's a great flexibility in what we can do with the experience. At the moment, we kind of deliver a scenario, which Susanne hinted at but didn't give away, with hidden surprises that come along for the students to deal with. That's certainly, you know, if the learning outcomes that you wanted to achieve were perhaps slightly different, we could certainly change the simulation in certain ways to give different kinds of surprises. Maybe, you know, make sure that they make a miscalculation somewhere. Because it's all behind the curtain, we're able to be benevolent or less benevolent, depending on how, you know, if we think they really should have double checked that measurement, for example, we might decide they either make it or don't make it to the rock they're trying to reach, for example, things like that. So I think, you know, we're very keen to use this going forward, but I think, you know, if we were to, we could run it like we did with the Sun students, which is basically our scenario with a group of students from all over the UK or beyond. But if we wanted to enter a kind of a relationship with another Sun university to deliver it on your curriculum, we'd certainly be open to the idea of working with you, understanding what you want to get out of it for your students, and changing the scenario if we need to. I think that's all I wanted to kind of highlight, and just to thank Sun for the funding. You know, it's a facility that we've just been using year on year, and the funding has really enabled us to start making this step to making it more widely available and improve some of the experience as well.
Yeah, thanks, Ben. Before I hand the floor back to Lucy, we got some questions of people in advance. And one is, are you using any Mars regolith simulant for the yard? No, we do not currently. And the reason being that this is a mission operations simulation. And when you look at simulations, you need to always ask the question, what am I going to simulate? We have 7 tons of sand in this. And so it is a cost question, whether you are modeling your landscape with something that is essentially builder's sand, or whether you are modeling your landscape with something that costs you several £1,000 a ton. But the place itself is more variable. We, for example, have a hole in the concrete bottom which we could fill with something, and which we could place a target to drill. We have a big shed door where we could open it and bring other materials in if that's what people want. The maximum thickness of the regolith is about knee deep in some. You see the things behind Ben, so I don't know if you can spotlight Ben for a minute. But the highest things are about knee deep. And what I could do is I can actually stop sharing. Here we go. And then we can all see Ben's background now. There we go. And so in the background, you see the front. Then there are two dunes, one with a rock on top, and behind there is the deepest area. It's about knee deep. Thanks, Ben. I think we can stop highlighting Ben now. And if you want to switch your cameras on so I can see who is still in the room. I talked about the learning objectives, and yeah, I think that's all the questions we had in advance. Thanks. Back to Lucy.
Well, first of all, a huge thank you to both you, Susanna, and to Ben for running the amazing workshop that you did for the Sun students who came from universities all across the UK, but also for this really fascinating talk, which has been really inspiring. It was inspiring to watch the Sun students, and it's been wonderful to hear the background and how thoughtful and how everything has been really thought through and is both exciting but also a great experience for the students, and obviously really brings them out of themselves. So a huge thank you to both of you for joining us today. Does anybody have any live questions they'd like to ask? We've had quite a few in the chat that Ben has answered, and you've answered some before, Susanna. So I've got one quick one, which is, what is the maximum number of students you can handle?
I think 18 is ideal, 24. Like we have 6 sub-teams, and more than 4 people in a sub-team, they start to step on each other's toes. So 3 to 4 per sub-team. 3 per sub-team is ideal. 2 work. If we have less than 12 people, it gets really tricky, because we then have roles with only 1 person in. And so if someone is ill on the day or something, or has other commitments, which we always, of course, have to factor in as a distance learning provider, then it gets really, really tricky. And so we have run in a very different scenario with larger groups. I see Valentina asked how would this scale. We have done things where we had a workshop for 3-4 days, and where we had tables instead of the teams. And because we were in the room, they didn't have to bother with the interface. They just did the thinking of the planning, and they told us what to put into the interface. We put it in the interface. Then they had another lecture, usually about Mars or something, while we executed the plan. Then we gave them the data, and then you can basically scale. If you have them in a room, you have a table, round tables of 5 or something, you can do that. And you have the leadership team, and you have the science team. It is, of course, a lot more compressed then, and they have a lot less time to think about it, but it works.
Fantastic, thank you. I think that might be useful to quite a lot of universities who have bigger numbers to deal with. So I'm afraid we're going to have to draw it to an end, but thank you so much again. Thank you so much, everyone who's attended, and we'll look forward to seeing you at another Sun webinar soon. But in the meantime, a huge thank you to Susanna and Ben for their talk today.